Okay, we're looking at composite and then inverse functions in this video. Composite functions are when you've got a function within another function. For example, this might be how you normally have a function. And the idea is that this x part is the input. And from GCSE, we put numbers in here sometimes. So sometimes you had f of 1. Okay, f of 1 like this. It meant change all of the x's to a 1. Or you might remember the x sometimes being some algebra, like f of 2x, written like this. It means change each x value to 2x. This one, in fact, actually, we're going to sort of do it this way around. We're going to have two functions. So we're going to have the f of x function, which is going to be like a rule. And then that's going to be the input to another function, in this case, the g of x function. In practice, it's probably best to just see a couple of examples to start with. So we're going to find g of f of 6. Okay, so I would normally write this like this. So we're going to find out what 6 is, first of all, in the f function, and then that's going to be the input to the g function. Let's do that. So f of 6 means what? It means take all of the x's in the f of x rule and change them to a 6. So it's going to be 8 times 6 minus 2, and then 7 times 6 minus 5. Okay, you put that all in your calculator. So 8 times 6 minus 2, 7 times 6 minus 5. And I get my answer on this one. So it's not a terribly nice number, but it is the number. Okay, so I get 46 over 37. Right. So f of 6 is 46 over 37. So instead of putting f of 6 in, you could think of that now as, instead I'm going to put in 46 over 37 to the g function. So how do I do this? Well, I write out that g function, but all of the bits that have an x are now going to be 46 over 37. So 3 of that, 5 of that, plus 4. Okay, so 46 over 37, 46 over 37. I put all that in, and that would be my answer. Okay, it says exact form because it's going to want it as a fraction. I leave it to you to finish if you want to carry on with that. Okay, that's with a number input. Let's have a look at an algebra input now then. So what does g of x mean? Well, it means g of x. Okay, here you can't really mess the order up because it's the same function both times. But again, start with the innermost bit, the bit closest to the x. Okay, so typically it's sort of from the right-hand side to the left is how it works in practice. There's no number here, so what do you do? Well, you just use the whole rule. The rule is up here. So I'm going to jump straight into saying for the outer layer, g of x would normally be 7. And then you have your input and you have your 5. Okay, but what's the input this time? Well, the input is actually the rule itself again. So that would be the input. Notice how I use the brackets there to make the process less confusing for what I was trying to do. So 7 times 7 is 49x plus the 35 plus the 5. Okay, so it's plus 40 in total. So that's how we would do that one. Let's try now then a more difficult one. So here are our rules. Up here, we've got f of x. We've also got g of x and h of x. So we've got 3 different rules going on. What are we meant to do here? So it says solve this. So the first thing you should do really is try and get these pieces. So what does hg of x mean? It means h of g of x. Okay, you're going to write out the h rule and you're going to change all of the x's to the g rule. That's how you're going to do this. So write out the h rule, which is 9, and then the input, and then cubed. And inside that bracket, what are we writing? We're writing g of x. So we're writing sort of the whole function itself. Okay, I'm going to change it to a slightly different format. So I'm going to change that to x plus 1 all to the power of a third. Okay, you're going to see why in just a second. So that's going to be x plus 1 all to the power of a third. Okay, So that is the left-hand side bit done. It says equals f of x, so I'm just going to set it equal to f of x, which is that rule over there. I'm going to try and simplify this now, and it says solve, so I'm hoping this is going to go somewhere. Power of a third cubed, well, they are going to just cancel out. So I'm going to get 9, and let's expand, shall we? 9x plus 9 equals 7 over x minus 1. Okay, what am I going to do from here? Well, I'm going to solve it. Okay, so what's the easiest way of doing this? I suppose probably putting that in brackets there, expanding those brackets. Yeah, I'm going to get a quadratic equal to 7, and then I'm just going to use my quadratic solver on my calculator to finish that one off. Okay, so get the pieces ready to work with is the main idea. Right, another one here. So a new function that you're going to see in the later lessons, f of x. This isn't used yet in this particular question, okay? But this is a special type of function, that one there. No need to worry about that yet, as it's not in this part though. So g of x. So with these ones, so I'm going to write out the rule 3 minus 4, the input, and the input on this one is actually the rule itself. So the left-hand side, well, the left part of the left-hand side is going to look like this. What does this mean? Well, this seems to say have the whole function and look where the brackets are and square the whole function. So the function, let's put it in brackets, is 3 minus 4x. Square the whole thing, set it equal to 0. Okay, and that's what I'm being expected to solve. So I would just expand this out. And it's going to be, of course, you can see it's going to be a quadratic again. I would just solve that quadratic. Okay, so those 4 examples there. This one was the only one with the numerical input. You had more algebraic ones, which is, yeah, this is probably a bit more common, I would say, A-level. But you saw a couple of ideas there. So putting in extra brackets I find quite helpful. Leaving spaces for the inputs. And then those 3 there were sort of variations of other. They're called composite functions, a function within a function. Right, we're going to have a go now then at some of these ones over here. So let's focus on these. Bit of notation for you. So that's how you write an inverse function. Now, you've got a function then and an inverse function. So how does it all work? Well, functions are about taking your value, your input, so the input might be the number 5, for example, and giving you an output for it. So let's pretend the rule for 5, for example, leads it to an output of 8. So that's what the function might do. So by definition, an inverse function, that's a -1 there, an inverse function is a function that is going to achieve sort of the inverse, the opposite, if you like. So for the inverse function, if we can go from a 5 to an 8 in the original, then an 8 should take us to a 5 in the inverse function. Okay, that's what it's going to achieve. So GCSE, largely again this one and how I would answer it. So I would set any f of x is equal to a y to make the manipulation and the writing a bit quicker. Then I would write out my rule for the original function. Then I would swap the x's and the y's, and hopefully that makes sense now why I would do it based on what we just said. So I'm talking about the inputs and outputs switching places. That's why this approach is going to work. So I do that. And then I rearrange again, so it's in the form y equals. So I'm going to move the 2 to the other side. So I'm going to say that 4y over 3 is x plus 2. And I'm just going to multiply by 3/4, I think, on both sides now to finish off that question. Okay, we're not too worried about the simplifying and so on here, but that would be the inverse function is what we're saying. And notation-wise, what I should actually write then is this. So the inverse function is 3/4 of x plus 2. Okay, and in fact, that's what they want me to write in that box there. Let's try a harder one then. So we've got a function, and this is the function. Domain, we're not going to worry about this too much just yet. However, this is going to be quite important later. It just means what values you're allowed to use. So if you look at the top here, you can see because of that square root and that -1, if you had a number like 0, that would be a problem because you'd end up with the square root of -1. Okay, and we're going to say that for A-level maths, that's not something we can do. So that's what domain is about, if you're wondering why that's there. It's saying the values you're allowed to input. So f of x is this, right? So I'm going to write it out with a y. We're going to find the inverse function. So it says root of x squared minus 1 of x. Now this one's more difficult, but the steps are largely the same. So let's swap these around first of all. So x equals root y squared minus 1 over y. And the goal is still the same here. It's just more difficult to achieve. If I move the y up to the other side, and then if I square both sides, okay, we're starting to get somewhere. I only want to see y once in one place. Y equals is the goal here. So I'm going to have to move these to the same side. So x squared y squared minus y squared equals -1. I'm then going to factorize the y squared, which will leave me with x squared minus 1 equals -1. We'll move that to the denominator. Okay. And then in this case, we can actually root this one. Okay. So I could do something like this. Now, this is a bit complicated, this one, but just to show you really the idea is the same. So that would be then the inverse function to the -1. That would be the inverse function in this case. So you've got kind of a crash course, really. Bit of a reminder, large overlap with GCSE, composite functions. Have a look at how that looks. 2 letters written next to each other is how it's presented in this chapter, and some problems with that. And we've got our inverse functions as well.